So we started here. I don't know where everybody's at. There's supposed to be like 45 of us here today. Did anyone have any issues with the room location, or it's consistently said this, right? At least on my end it has. Okay. So I'm Professor Lannis. This is E371, Introduction to Econometrics. Today we'll kind of be going through the syllabus. I'll probably briefly kind of start on a little bit of review material. Most of you probably have taken 370, right? Or if not, you've taken, I'm still learning, this is my second year. What's the equivalent? Has anyone taken it from the stats department or no? Okay, so we're all E370s here. That's good. So I've got the Canvas page kind of pulled open here. Also, technical difficulties. I don't know why this won't turn on. I checked the things. We'll use the dot cam a lot in this class. I guess I'll go old school. If I have to do anything on the board today, I'll use the chalkboard. But you kind of already noticed I start recording these classes as soon as I start. So it'll record anything I do on the screen. The only thing is it won't record anything I do in the dot cam. So it's not a perfect substitute for class, but if you do miss class, you can kind of go back and I'll put those on my YouTube page. The link, it's in the syllabus right here. Or I always tell people probably the other easy way to do this. I can't see, sorry. Go to YouTube and you search Professor Lannis. I'm the person that shows up. Right now, I think the only playlists that are out there are these three. So actually, I've still got my 370 stuff out there from the summer. I've got two different sections. I've got a help video about something we'll talk about later on in the class. It's already up there. But this is where I'll be posting after class the lectures. Okay. And apologize for being a little bit dressed down today. I'm in shorts, I know, but it's too damn hot. I've got a 20-minute walk here and a 20-minute walk after this to the next class. So it's going to be a brutal one today. All right, so go back to the slides here. There we go. So go back to Canvas. All the materials for every week will kind of be up here on Canvas. So I'm going to try to kind of do this in modules. You can think of them as chapters, but it's basically like module 1 is week 1, module 2 is week 2. As we get towards the end of the semester, there might be a little bit of bleed over in the sense that I think the IV, instrumental variable stuff, will probably take us 3 class periods. So that I think the data issues chapter probably takes 3 as well. So it may, it's not perfect week to week, but essentially it's like week 1. I've got this up here. It's not for points. I just want to mention this right now because it helps me get to know you guys a little bit better, what your background is, what your interests are. I've got a survey, just a background survey. It kind of asks, what your freshman, sophomore, junior, what interests you about economics. I give you some options, kind of different fields. This kind of helps me cater the class a little bit more towards you guys. So if you could get on and get that done by the end of the week, that kind of gives me a better idea of the examples I'll use in class and kind of where I'll direct things. Like if you're all interested in I don't know, industrial organization, I'll try to bring in a lot more company-based examples. But a lot of you are interested in health-related issues. I might have a cigarette use data set or something like that. I always put the slides up for the week as well. Occasionally, I'll put up what I call skeleton slides, where I leave a couple things out if it's things that I don't want you to know ahead of time in class. But I'll always post a complete version at the end of the week. Right. So right now, we kind of got those slides up there. I haven't dragged the data sets in yet. I will eventually once we use them more on Thursday. But if you go to the Files tab, I try to kind of keep them by the weeks as well. That one I really will keep by weeks, and then once we get to the topics that cover the 3, take 3 class periods, I'll start putting the name of the topic. So, excuse me, under week 1 materials, I'll also put the slides, but also these data files. So, we're going to be working with a lot of data sets throughout the semester. And so each week I'll put whatever data sets we're going to be using in class up here under the Files tab. Like I said, I'll actually put these also on that first homepage under the module 1. I think we'll use some of them today, but we're really not going to use them a lot until next class. So I'll have them up there for next class when I'm going to have you guys using them. Okay. So with that in mind, I'm going to hop over here. There it goes. There we go. Sweet. So what do you need for this class, right? Today I'll kind of walk through the syllabus expectations, and then we'll do a little bit of review material from 370. So I think the book that I have for this class is what, the Stock and Watson book. I'm not gonna like follow it to a T. It's a good reference, right? Anything I expect you to know will be something that's in the slides or that we've done in class, right? But if you want a textbook and you want to have some additional material, that's the textbook for this course. I would not go out and get the 4th edition. It's going to be expensive. It's the same edition as the 2nd and 3rd. They're just trying to make money, right? And so if you go out and, I don't know what the best website is for old, used textbooks now, but if you get the 2nd or 3rd edition, you can probably get it for pretty cheap. I'll use the Canvas website, primarily like all the files, everything will be up there. I'll use the announcements on there to kind of convey anything to you that I forget to tell you in class, or important things I said in class, but just want to make sure if you weren't there that day that you know that whatever that is. And then I would highly recommend having a tablet, laptop, smartphone, but the smartphone, this is not really going to work. But having a tablet in class is going to be having a laptop in class is going to be, I think, really important, right? Because when I work through these data sets and I show you what we can do in this program called STATA, working along with me is going to be really helpful. Now, if you know it's going to be a distraction for you, try not to have other tabs open, right? Try not to have, I don't know, ESPN open, looking at scores or whatever you're interested in. But having a laptop working along with me on those examples will be really helpful. If you don't want to have your laptop open or work along, you just want to kind of focus. You could use a smartphone for what I'll use occasionally, talking about them more in depth in a second, but like in class quizzes, but I just use Canvas to do so. So technically you could do it from your phone. It's just like open them, like start them at random points in the class, and then I close them out like 5 minutes later. So you never know when they're gonna be. If you don't show up in class, you don't know when I'm going to use them during class. I guess technically if you wanted to sit in your room and just keep an eye on it for the entire class period, why the hell didn't you just come to class to begin with if you're going to take that chunk of time to do that? And I'll use those kind of periodically, just random throughout the semester, okay? So you can do those from a smartphone, but laptop's probably your best guess or best bet. Calculator is going to be helpful, especially when it comes to exam time. We're not going to do anything too crazy in this class. We might have, we will do more than just addition, subtraction, multiplication, probably some exponentials, but nothing wild. So you do need like a basic 4-function calculator that you can at least take something to a power, right? And if you have something more than that, that's okay. If you have like a TI 83 or whatever, that's okay as well. I've already mentioned the lecture slides. I'll put a skeleton version up, complete version after class on Thursday. I'll put the recordings up here. Now, once again, these recordings, they're not going to be perfect. You probably already noticed I'm standing over here, so I'm guessing it's not captured. I move around a lot, and this is not on my mind. This is just something that I know I can do very quickly, and at least capture some of it. So if you do have to miss class or you do want to go back, you do have an additional resource. But I'll tell you, when I'm teaching, I forget about it sometimes, and I'll move around and won't have anything on the dot cam. It's just going to be recording the screen and the audio. Okay. Any questions from you up to this? But I already mentioned the YouTube link. You can kind of find that channel there. Any questions from me so far? Okay. So what do you guys care about? How are you going to get the grade that you want? Hopefully you all want an A, but how are you going to get the grade that you want in this class, right? So kind of break this down. We're going to have 2 exams, a midterm and a final. They're both going to be worth 32% of your grade. Okay. So pretty heavily weighted on the exams, which makes them very important. And I also realize this. So usually, I think we should be able to get at least 1 full class period where I just do review before the exam, right? Sometimes I get a little bit more, but I don't like to promise that. I can only promise a class period, but I don't know if I can promise more. But sometimes we'll have maybe 2 class periods or a class period and a half where we start reviewing for that upcoming exam. Okay. The exams will be here in class. If you do have an accommodation, you need to get that to me in this first week, and we can figure, we can work something out. But otherwise, they'll expect you to be here on the exam dates, and I don't have them in this slide. I don't think they're in the syllabus, and I do have them later on. So if you know you're going to have an issue with one of those exam dates, let me know well in advance ahead of time, and we can work something out. If you let me know after the fact, it's a lot harder for me to do something. Okay. Problem sets will be 24% of your grade. So we should have, I think 6 that I have here. Yeah, 6 different problem sets. So I'll go more in depth into those later on, but 6 different problem sets, making them what, each word 4%. So they're really going to be heavily data-based. So like it's going to be you working with this program called Stata, which we'll take a look at here today a little bit. You'll have, anytime these are assigned, you'll have at the bare minimum at least 2 weeks to work on. Sometimes a little bit longer. Once I said, once we get towards the end of the semester and we have these topics that take a little bit more time, you'll probably have a little bit more than 2 weeks to work on those. Okay. The quizzes, I'll have, there are going to be 6 different quizzes. They'll be like every 2 weeks, with the exception of like during exam weeks, there won't be one. So assignments, similar kind of thing. They're about every 2 weeks, but you know, then when we get to an exam week, then it's 3 weeks between those 2 assignments. So you can kind of think about before the first exam, we'll have 3 assignments. Then after that exam, we'll have another 3 assignments after that, right? So they're about every 2 weeks. Same thing with the quizzes. The quizzes will be on Canvas. They are assigned after class on Thursday, and they're just due by the time we start class that next Tuesday. So you'll have what, 6-ish days, kind of work that into your schedule to kind of sit down, complete that quiz. I'll get practice problems up for those when I do post them. So you'll have a set of practice problems to kind of look at, give you an idea about what the kind of questions will look like. It's open book, open note. These quizzes are meant to be, I mean, it's 12% of your overall grade, so it's not a ton, right? But it's a lot more effort-based. So I say like everything, and there's a lot less of this in this class than there are that I put in like introductory classes, but everything in life is ability and effort, right? So you think of it as like a function, right? Your grade is always a production of your ability and your effort. You can have all the ability in the world, if you don't show up to class and don't put assignments in, you're not gonna get a good grade, right? I try to make these a little more effort-based, where if you sit down, you've got the notes that you took from that, previous 2 weeks, you've got the slides even open as you're taking this quiz. Like, this is open book, open notes. You should be able to do pretty well in these quizzes, right? If you take them seriously, I think these are more effort-based even than ability, okay? Is that any questions on that? Also, I didn't mention, when you do start them, it's not like you can work on them across the entire 6-day period. When you start it, you'll have 60 minutes to kind of complete it, right? And they're generally about 12 questions, so 5 minutes per question. I write them so that time shouldn't be an issue. If it starts to be an issue, feel free. I'll always take feedback. If I'm giving you things that are taking you a little bit longer, I might play around with it. Maybe I'll give you 90 minutes or something like that. But I think 60 minutes from my experience, and I taught this last spring, was always more than adequate. Any questions from you before I came? I hate like the first, I gotta do a lot more talking, so if you stop me if you have any questions, it helps me out to take a breath or catch my breath. So it's not required that you show up to class, although it's heavily encouraged. This is my 2nd year at IU, and I can tell you from the spring, and I didn't teach econometrics at the university I was at before. I taught like 370 essentially. And this is true about that class as well, but this course even more. I saw that when people started to fall behind, it was a definite snowball effect, right? Like you start missing in one class, and then, and you get a little bit behind, and miss another, you get even more behind. It really kind of, exponentially like hurt their performance in the class. So really coming to class, keeping up on things is really, really important. Because everything we do in this class, literally from day 1, is going to build on each other. Like it's not like there's really separate topics almost. Maybe you could argue towards the end of the semester it kind of is, but it's still using stuff that we learned earlier in the semester. So it's really important. That's why I'll give some points for those in-class quizzes that I use, in-class participation, because I want to incentivize it, right? How many of you guys are econ majors? So yeah, you're incentivized, right? I'm incentivizing you. I'm tying some value to you showing up to class. I'm not doing that to be mean. I'm doing that to help your grade out, to get some easy effort-based points, because I'll tell you right now, sometimes I'm really nice, like today, if I was using an in-class quiz, what I might do is say, well, look, I know most of the class is not here. For whatever reason, a lot of people aren't here today. I might heavily hint towards what the right answer is when I put the question up there. Like, maybe just kind of hold my hand out or something like this, pointing at the correct answer. So these are meant to be more effort-based. They're just more so, I can't stress enough how important it is to be here and be present, right? So 10 random class periods. So it's all going to be extra credit, so you can earn up to, it's not a whole lot, but if you do all 10, it's 5%. It's a nice little buffer for your grade. That means, if you got an 85, you bump your grade up to an A minus. So, I think that's very generous. So this, to me also, like I said, I think this is a pretty strong incentive. When you say 0.5% of extra credit for each one, doesn't sound like much, but 5% at the end of the semester is a lot, right? And I do this because I know that the problem sets are difficult, and I know the exams will be difficult. Right? So I try to build in some other cushions in other areas of the class, and that's one of them. So the problem sets, like I already kind of mentioned, we'll have 6 of those, similar to the quizzes, about every 2 weeks, and they'll generally kind of be along the same due dates as the quizzes. Sometimes I'll make a little more time on the problem sets than the quizzes, but generally every 2 weeks you'll see a problem set pop up. And the first one we won't really have up there until next week, so we just haven't covered enough material for me to kind of give that to you. Okay. I already mentioned we're going to be using Stata, so this is going to require us to use, a lot of you, do any of you have Stata on your computer? Yeah, I wouldn't expect you to. I don't even expect you to know what it is, right? But you don't have to go out and buy it because the university has a license to it, right? So we'll walk through the steps here in a little bit of how you can kind of get this onto your device. But when I give you these assignments, they are meant to be done in Stata. You will not get the full credit if you type things that are just write out your answers, right? You need to be using Stata to answer every single one. Now, in fact, it doesn't even make sense in a lot of them. There's nothing you could really write. First of all, I'm giving you some data sets that have thousands of observations. You can't, I pray to God, you're not trying to do the math by hand, right? So you should be uploading eventually, and this will make more sense as we work through more stuff in class, but your Stata code, right? As well as in kind of, okay, what output do I get from Stata? Now I can use that to answer these questions. Okay. So these are worth a pretty big chunk of your grade. Once again, I know the exams are a lot and they're kind of tough. These will be tough as well. I'll grade them pretty rigorously, but you have a lot of resources available to you. We'll go through an example that looks almost identical to what I asked you to do in the problem sets. Also, my office hours, I would highly recommend, if you get stuck at all, stopping by those. I think that was a very effective tool for a lot of students in the spring when I taught this. So take these kind of seriously, right? There we go. Important dates. So I've kind of got, I don't know, the midterm is probably the most important. I've got some university related dates. These are all at the end of the syllabus as well. And then our exam slot kind of given to us by the university, which is a little bit later in exam week, but is on that Thursday. All right, so know these ahead of time. Make sure that you have any conflicts that you make me aware far in advance. Okay. Questions? Also, not very good with math. I had a typo there. I think I changed it around from last spring. I gave a little bit more percent of the grade. I took away a little bit from the exams and put it towards the problem set, so I changed things around a little bit. But I think ultimately I did that to help you guys. Okay. So with this in mind, of you letting me know things in advance, I have something to let you guys know in advance that may cause a disruption later on in our semester, right? So hopefully this won't be until mid-November, but my wife's pregnant, so I might have to cancel class very unexpectedly. So just be aware of that once we get to November. Keep an eye on Canvas for the announcements. I'll try to use that to communicate with you outside of class, and we'll kind of adjust the course accordingly when that happens, okay? Hopefully, it doesn't happen on Tuesday or Thursday. So, any questions from me before we kind of keep moving? Okay. So, how do you succeed in this class? Reading the book. I say to read the book. I don't necessarily want you to kind of go through the book. The book for this class really is going to be the slides. So one thing I think is helpful, I'll always have the slides posted up. I'll probably post next week's slides up after class Thursday. So just taking a glance at them. I always think priming your mind for something, this probably applies to any of your classes, just at least skimming through it and just kind of looking at some terminology and just kind of what we're going to be talking about. I think it just makes it so that in class, you don't have to worry as much about these little things, and you can kind of, I don't know, I think it helps the learning process to have a starting point going into class. So that would be something I would suggest, not just for this class, but every class. Show up to class, right? I can't stress how important this is, because it's This like class probably more than any other. I'm sure there is stuff out there like on YouTube, but it's not going to be. It's going to be harder to find help on working with state. Right? Some of the topics that we'll talk about, there's probably plenty of other stuff out there online that you can find that might help you a little bit, but it's not going to be exactly what we covered in class, and it's not going to be, I think, as helpful as I try to cater these examples in class to really match up with the types of questions I'll ask you in problem sets and exams. Practice, practice, practice. So I'll give you these like practice problems before the quizzes I mentioned. Also, the book has some end of chapter questions, which are just good to kind of work through as well if you're looking for additional stuff. And then once we get to the midterm and the final, I'll also post up like practice exams so you can get an idea about what types of questions I'll ask. I didn't mention this earlier, but the exams will be kind of a combination of like multiple choice, but then like half of it's going to be like short answer as well. Right? So I'll write the practice exams to look similar to that. Okay. Take the quizzes seriously. I kind of already mentioned this, but have all the materials out in front of you. Like I'm wanting you guys to get as many of those quiz points as possible. And I think if you take them seriously and you're like ready to sit down, everything in front of you, I think you can do pretty well on those. Okay. I mentioned it's open note. I'll also mention at this point, one of my favorite quotes by Michael Scott. Right? You miss 100% of the shots that you don't take, right? And if you guys haven't watched The Office, I know it's kind of an older show now, but it still holds up. So I can't tell you, like, I mean, hopefully you've taken 370, and hopefully by the end of this semester you'll realize why. But zeros can really tank your grade. Like they really pull your grade down. Even if you know, I don't know. Oh shit! Like the quiz is due before class. I'm here an hour early. I gotta take it right before class. I'm not really prepared. Just get on and guess. A 50%, a 25% is a hell of a lot better than a 0, right? So, I guess, make sure you're getting something submitted for these problem sets. Even if you had a bad week, you didn't put in a lot of time, try to get something out there. Some points is a lot better than 0. 0 just pulls that grade down so much, it's harder to recover from those, okay? And I don't think I have it up here, but I don't know what other professors do. I don't necessarily, well, I care, but I can't influence it, so in essence, I don't care. There's no late work. If you turn something in a day late, don't email me, can I get 20% taken off or half credit? The deadlines are the deadlines, the due dates are the due dates. If you don't turn something in or you don't submit a quiz by that time, it's a 0, and that's really gonna hurt your grade, okay? I mean, you guys are probably don't have, there's no freshmen here. Yeah, I was gonna say, you guys hopefully have I teach the big B251 sections in like, I mean, they're children still, I feel like. So you guys, I think, have things a little bit more under control. I probably are used to kind of these processes. Like you got to make sure you're getting things in by the due date. Okay. I also will get this updated. I wasn't getting information until yesterday, so I haven't gotten to get these files updated. I now know who my GA and my TA are. They'll have some office hours. In fact, one of them I believe is going to do their office hours virtually. I've heard. I don't know how I feel about this. We'll see how it goes. It's kind of a trial run. But I know that for some, I mean, I don't like making 20-minute walks across campus. I'm sure sometimes, like when it's 95 degrees out, you probably don't want to either. So if you do want to meet with them, they'll have office hours, but one of them are going to be on Zoom. So I'll provide that Zoom link. I'll get that up in the syllabus and also on the slides and get those updated probably later this afternoon, if not tomorrow for sure. Excuse me, but I do have a GA for this course, and they've taken it, they've done excellent. In fact, the one is doing like crazy, like simulation, like data simulations. So like their econometrics are insane. So that they'll be more than that, or more than capable of helping you. However, I would say default. I personally don't love, like, lecturing's okay. I don't mind it, especially when it's a smaller class like this. I like when people stop by my office and that one-to-one, getting to like know people, getting to like kind of help you one-on-one. So please, if you ever want help or want to, you just want to talk, stop by my office hours, 12:30 to 3:30, Monday, Wednesday. If those don't work for you, send me an email. We can find another time, likely. I'm on campus like every single day. So, which I say that, and then I have to take the caveat. This is kind of a weird week. Obviously, Monday, the office hours, we haven't even been in class yet. So I'm going to move my office hours. I'll be on my office this Friday from 12:30 to 3:30. And honestly, most Fridays I will be. I just can't promise every Friday I try to use that time to schedule more meetings. But Monday, Wednesday, 12:30 to 3:30, I'll always be available in my office. And then this very first week, fortunately Wednesday, I'm gonna be kept away from the university, but I will be able to meet via Zoom. So you can always meet in person. If you do want to meet with me via Zoom during office hours, send me an email. I have a meeting ID created that's reserved for these time slots, Monday, Wednesday, where we can always meet via Zoom during these office hours as well. This first week is just a little different. Okay. Does that make sense? Any questions on that? And I'm over in Wiley, up on the 3rd floor, 309, which is a hike from here, but help me help you, right? Does anybody know who this is from? Joe McGuire. Thank you. I'm starting to feel older and older, and people aren't getting my references. So I'll drop in TV and movie references probably throughout the semester that I like, just because I don't know, keeps things interesting. So the goal of this class, right, is we're going to try to, and we're going to start out slowly, but we want to try to get to eventually estimating what we call causal relationships. So we probably talked about in 370 a lot about like correlations, right? We can always look at data and see that, yeah, what's a good example of this? You know, getting the flu vaccine likely is correlated with not getting the flu as often. But we got to think about, is that really a causal effect? Not saying that the flu vaccines work, but here's the thought, or here's the thought process. Who's getting flu vaccines? Well, probably people who are worried about the flu killing them, right? So it's going to be people who are already compromised in health. So in fact, we might see that getting the flu vaccine looks like it's more likely you're going to have negative health outcomes. They might be negatively correlated, but no one thinks the flu vaccine is causing people to get sick and die. It's that people who are getting, I'll be honest, I don't get the flu vaccine, I don't care. If I get sick, I'll get sick, I'll be all right, right? But if I was 85, I'm probably gonna go out and get the flu vaccine, because I know if I get the flu, that might be the last time I get it, right? So we're gonna try to tease out, and that's like a selection issue. There's a lot of other issues that we can see that the correlation exists, but is it causal? And there's a way that we can control for things so that we can make sure we're getting a causal relationship. So I think the other class I had, or example, does class size impact student test scores? We can see that there's a correlation there, but like what types of students, maybe, so I'll use an example. I know that like a 251, most of them are like 300 student sections, but there are like some that the GAs and TAs teach that are like smaller. Well, maybe it looks like class size is like having a negative impact, but maybe it's really not. Maybe it's like the students that are on top of things more that we're scheduling on time, we're getting these preferred smaller sections, or maybe it's some university, the way the university was assigning students to these TAs. Also, TAs might not be as good of teachers as the professors that are teaching in 251. So we might have this correlation, but we really can't say it's causal. We have a little bit more work to do before we can say it's causal. Does an individual's race kind of impact mortgage denials? So this is another one. Once we have the data, we don't have like a selection issue thing going on here, but we can really get an idea of like, yeah, are people of different race, are they being treated differently by these companies? Like, these are important questions. If we can get our hands on the data and answer and figure out, yeah, in fact, being of a different race or being, whatever the racial category we're interested in is actually they're getting mortgages at higher percentages. Well, that's a problem, right? Once we know that's a causal relationship, we can identify that, we can go out and rectify it, or we can, hopefully the government does something against the companies that says like, hey, this shouldn't be going on, right? And unfortunately, we see things like this pop up being causal occasionally. Do cigarette taxes reduce smoking, right? Why might cigarette taxes not actually reduce smoking? I'm throwing you back to just get some econ talk here. What do you think people who smoke cigarettes, what's their demand? Pretty inelastic. So if it was perfectly inelastic, I'm addicted, I gotta smoke, I need a cigarette every hour, right? Doesn't matter what the price is. What happens when they tax it? I keep using the same amount, I just pay more money to these companies, right? So these are interesting questions, and we can tease this out whether or not how elastic the demand actually is by using data on cigarette usage or cigarette sales and cigarette taxes. Okay? So we can also make predictions. This is gonna be another important thing we start doing once we dive. And you guys probably covered, I'm hoping that your 370 instructors covered linear regression. No? Nobody covered linear regression in this 370 class? I mean, it's okay if they didn't. Like, they didn't? Can you confirm? Yeah.
We did like a little bit.
Just a little bit, yeah, right? They just introduced the idea. Yeah, okay, that's all I'm saying. I was getting a little worried. But some of you not hear this term at all ever? 370? Can I get a yes or a no?
Like I did it for like a week.
Okay, so they sprinkle up. We're basically gonna be diving deep into regression in this class. Okay, we'll start out doing some review and I'll review it, so I'm not assuming that any of you know it. I'm starting out, we'll cover linear regression like you've never seen it before. But we can use that to make predictions, right? We can use this regression output to start to make predictions. So, you know, we can actually make, looking at historical data, you know, looking at job reports and looking at different measures of the economy, we can predict what the GDP is going to be in the following year, right? I said 2024, so we can predict kind of what it's going to be at year's end, right? So to answer all these questions, we're going to be using data sets. So different types of data that we're going to look at. We've got cross-sectional. Let's see, gotta keep an eye on time, so we do it. Which is going to be when we have information collected all at one period of time, but multiple subjects. So this would be like if I had everybody's grade in this class, right, for this semester. At one point in time, they've got multiple subjects' grades. Right? Time series data would be like if I chose one subject, so I chose you, and I looked at what your GPA was every single semester. Different points in time, one subject. Okay? So that would be the time series data. And then going to kind of mash those two together. And this is primarily the types of data sets we'll be looking at. In the first couple of weeks, we'll probably have a lot more like cross-sectional and time series because we'll be doing some basic stuff. But as we get into future topics, we're going to be using primarily panel data, which is I've got several different subjects at several points in time. So this would be like I had every single person in this classroom's GPA every semester for the previous 4 or 5 semesters, right? Multiple points in time, but for multiple subjects, right? So we're kind of mashing those two together with these panel data sets. And these panel data sets allow us to answer even more interesting questions than the other two, usually, depending on the topic, right? So just to kind of give you some examples, I just threw some out there, but what is this? I used, population data. So it's a little bit old, it's 2020 data, but this would be an example of cross-sectional data because it's all at one period of time. It was all in 2020, but it's for multiple different cities, right? So this is a nice example of cross-sectional data. Here I've got time series data. So this is where it looks a little bit different. So initially you're like, oh, well, I've got multiple columns now. This can't be time series. My example earlier, I said it was one student at several points in time. Here I've got several different countries. Well, this isn't time series data. It's still all in one year. So it's still cross-sectional. But then why do I have multiple columns? Because cross-sectional data, we don't just have to have one variable, right? We can have multiple subjects, right, in multiple countries here. It's all at one point in time, year 2011, but I have multiple variables collected, right? I've got their what? GDP per capita, primary education expenditures, and secondary education expenditures. Right? So cross-sectional data can still be very large because we can have, you know, we've got every single country, even though it's at the same time period, we can collect a lot of information about those countries. So our column, or our columns here, we can kind of think of represent what we're going to call variables, right? So each column is a variable. It's something that we're collecting data on for each one of our subjects, right? And our subjects here are countries. Okay? I think if you look in the book, or if you look out there and find, I don't know, if you're Googling it, sometimes instead of subjects, they'll use the term elements. That's a little bit more like math. I don't know. I think like the real math geeks probably say that. I always call it subjects. I think that just makes a little more sense in how we view a lot of the different examples. Time series data. So this would be where I have like the US and I have the unemployment rate and I had it for a bunch of different years. Right? Same kind of thing. I don't just have to have one variable. This time series data could have multiple variables. I could have had the unemployment rate. I could have had what the US GDP was. Maybe I have what the even average kind of expenditures on education by my people were in each one of these, or in this country in each one of these time periods. But this would be a nice example of time series data. Just trying to give you more to kind of gonna put this together here. And then I had some old data sets. So how many of you went to elementary school in Indiana? Okay, not many of you, right? But you did. And you were taking the I-step. Do you remember the I-step? So it's like, I don't know, every different state, like I think it's the M something in Michigan. There, all these different states have their own like standardized testing. For if you were in elementary school in 2000, or not elementary, sorry, it's grades 6 through 8. In 2009, 10, or 11, I have a data set that has your I-step score in it. I can't identify you by name. The state wouldn't give me that, but they would give me all of the scores of different students, right? So here I've got a nice panel data set where I could actually look at the same student in year 2009, 10, 11, and ignore the commas. This is just like a weird formatting thing that Excel didn't like put it in here. But yeah, I could follow that same subject across multiple periods of times, but I not only had one subject, right? Here I had one person. I also had a second person, and they were, you know, those 3 years. Third person for 3 years, and so on and so forth. Right? So this is a good example of a panel data set. Okay. Any questions on anything else? Like I said, this first week is really going to be me probably like reviewing a lot of things that you talked about in 370. Some of them might seem really easy, but starting out kind of slow here. So what do I want to make sure? Get out of here at 11. Okay, we'll go a little bit longer and then we'll kind of switch over. I want to show you kind of how to use that program's data and how we can kind of start to get down our laptop devices. So I want to make sure I set enough time aside for that. So just some basic review that we'll start talking about. So we go back to 370, we're talking about statistics. Anytime we're talking about population data, that would be like I had, let's say I was interested in the average alcohol consumption of an IU student, right? I would need population data. It would have to be the recorded alcohol consumption of every single student. That's population data. That's it doesn't have to be when we say population. It's not like the population of the U.S. If I'm only interested in a very specific group, like Indiana University students, that's my population, right? So capital N is how we're going to represent this population. The number, right? Capital N is going to be a number, and that's the number of observations we would have in the population data set. So different examples. I use the IU and every IU student, but if I was interested in like every U.S. citizen, well, now my population has to be a lot larger, right? That'd be a gigantic data set. I could do countries. I could do maybe just, I want to only be interested in, well, how are automotive firms affected by some new emissions standard that the government put out, right? Well, then it's just my automotive companies would be my population. You do every Indiana, my I-step example. I want every single Indiana school, right? I don't care about Ohio school. I don't care about just focus on Indiana. We're also going to start denoting the variables that we're talking about. We're going to call them random variables because until we collect the information, they can be a bunch of different values, right? For instance, the I-step score. It has a range, but if I just choose a person at random, it could be any one of those numbers. It's a random variable until I actually choose and record what the value is. So I'll kind of denote random variables, these variables we're talking about, with a capital Y. And we can use capital X as well, but this is generally the notation I'll use. Okay? And I use a single, we can do the average test score of a school. And until we select that school, we don't know what the average test score was in that school. You probably remember, hopefully, a little bit, we talked about different distributions in 370. In fact, I made that plural. You probably only really talked about two, right? Standard normal distribution, right? And what other one? A skew distribution. You could talk about distributions with skew, that's correct. But also maybe the student T, right? That's kind of the primary two. And in fact, you'll see in the files tab, I already have those tables up there. We'll use them a little bit on Thursday. Those will be kind of the two distributions we start out with. I'll actually introduce, I think, only one other, maybe at the end of this semester, another second. So only two additional distributions. So we're really going to heavily focus and think about this normal distribution, standard normal distribution. But to your point, it doesn't have to be a normal distribution. Anytime we look at data, it can have skew to it, right? And we'll talk more about skew and we'll look at some different examples of it here. I don't think today, we'll probably get to that on Thursday. So I might be interested in not only continuous data, but we're also going to be looking at examples where it's discrete, right? So here I said, what's the probability that this random variable y is equal to 10? So maybe I'm interested in something like this. 10 doesn't make a lot of sense here, but we'll run with it because it is possible. Maybe we're interested in, okay, if I select a family at random, what's the probability that there are 10 kids in the household? Probably relatively low, but there are some, right? What's the probability that this random variable, the number of kids in the household, would be 2? Well, that's a lot more likely, right? What about 0? It's pretty likely as well, right? So, but all of these, we can tease out, figure out from data what these probabilities are, right? But these are going to be the types of questions we're interested in. And sometimes it's just a street. You can't have, well, pray to God, you don't have half a kid in your household, right? So we might have these examples where it has to be an integer, right? So, in fact, we want to get real technical. Even these ISTEP scores are technically discrete because they're scored by points. There's gaps, right? I can't get a 341.5. I can only get a 341 or a 342. So sometimes what might look originally like a continuous variable, we want to get real technical, it is an integer, right? Now, once the range gets wide enough, we can treat these like they're continuous variables. But like for the kid example, there's such a small number of values we can see, we want to make sure we're treating it like a discrete random variable. I could also do things like, okay, what's the probability that it's equal to a specific value? But maybe I want to know, okay, what's the probability it's in between two values? Right? So what's the probability it's in between 10 and 20? Or maybe my master, what's the probability it's in between 340 and 360? We can do that as well. And we just start writing it, what's the probability this random variable is in this range, right? Greater than this value, less than this other value. Here's a nice continuous distribution. So it wasn't discrete. So this one on the left was individual actual scores, so student scores. I then look at the average scores of a school. Well, think about it. If I'm taking the average score of a school, it doesn't have to be an integer anymore because I'm averaging across multiple. I might end up with 341.123578. So here, this is for schools. I get this nice kind of continuous distribution when I'm looking at the average scores across these different schools. Okay. Is that making sense so far? Here with this, trying to move slow here. Just some other stuff just to kind of get some notation out of the way. So hopefully they reviewed these with you. Maybe they displayed it in a slightly different way. You can kind of write summation signs a little different. So this, what's this Greek letter I've got in that second line? Is anybody Greek life here? Sigma, right? Yeah. So sigma is basically the summation sign. So what it says is take whatever is on the right side of this Greek letter, this sigma, take whatever's on the right hand side of it and go through, starting with the very first observation, go to the fifth, and add up the number 2 every single time. So the first time you'll have 2, then you'll go to I equals 2, so you'll add 2 again, 4, you add 2 again, 3 or 6, add 2 again, you get 8, add 2 again, you get 10. You stop at that 50. Now, we're not going to use it so much like that. That is how you would do that. Usually what we're going to have on the right-hand side is going to be these random variables. So what our summation sign of a random variable is telling us to say, okay, look, we've got this capital N, so population data. So maybe it's every single student in this class and what their current GPA is. It's going to say, okay, look, go and add up, starting with the very first student, take their GPA. So y, lowercase y1 is, what's my first observation's value for this random variable y? So what's the first student's GPA? Then go to the second student. Add in the second student's value for this random variable y, their GPA. Then go to the third, the fourth, the fifth, all the way until you get to the very last student, right? Or once you get to the very last observation of your population data set. Just looking a little bit familiar, hopefully. Okay. Like I said, I'm starting off with pretty easy here. We'll kind of get some easy ones out of the way as well. And we'll see how we do this in Stata on Thursday. So I'm going to kind of throw a couple of this out there. Usually, after this first week, we'll cover something, and then we'll see how we do it in Stata. We'll cover another thing. How do I do it in Stata? This first week, because some of it's kind of easy, I kind of will do it more like as a larger block, and then we'll do like a larger block of Stata as well. So measures of central tendency, just kind of a fancy word. Typically, the one we're most interested in, is the mean, right? Or what we call the expected value of this random variable. So mu here, with a subscript y, means this is the mean, or the population mean. Anytime we use Greek letters, this is just for kind of the whole semester, Greek letters are kind of telling us population data. Anytime we're using like alphanumeric or English lettering, and it's like lowercase, that's generally going to be our sample data. So that might be, I only have a small subset of the population in my data set. But for now, we've got kind of the population data. So it's, once again, go through every single observation, whatever your random variable y is. Maybe this is, I want the average GPA of this class. I added up every single person's GPA. That's what that summation sign was doing. And then I divide it by the total number of students I have in this class, or the population size, capital N. Okay? And you probably had to do this by hand. We can do this much. You probably didn't. Did you guys use Excel in your 370s? I use it in mine, but it's a lot easier to find means and things in Excel than it is to do this all by hand. But this is what Excel would be doing behind the scenes. So there's going to be a lot of this where I might show you formulas in class, and I'll talk through the intuition behind what the formula is doing, right? Just so we have some idea, because just like Excel, if you type in average, it'll do all this math for you. Well, you don't get to see what's going on behind like this, we call it a black box, right? You don't see what it's doing behind the scenes. So I always tell you kind of this is the equation that's using behind the scenes, but now how can we just make it really easy, not do it by hand? How can we use Stata to do this? If we have a discrete random variable, what we would do is we would take the probability associated with seeing each different value, multiply it by, or what do I have here? Yeah, so I would take the probability that I saw the specific value, multiply it by whatever the actual recorded value that y variable had, and then add them all up. We don't need to divide by n there, and we'll dive more into this a little bit deeper. But when we're talking about probabilities, it's kind of like the divided by n is already built into that probability. In fact, if I look at every single outcome, so let's say I took the probability that there was 0 kids in a household, plus the probability there was 1 kid in a household, and I went all the way up to whatever the Duggars have. Right? I think that's the TV show family. Might be saying it wrong, but add all those up. What should they always add up to? 100. Yeah, 100%, or the probability of yes, 1. Yep. And this is another key point. Well, I tend to default to talking about things in percentages, but we can always go back and forth in between probabilities and percentages by doing what? If I've got a percent, how do I turn it into a probability? 100% would be a probability of. So what'd you do there? You divided it by 100. Yep. And we can go the other direction too. I know the probability is 0.2. What is it as a percentage? 20%. What did I do there? Multiply by 100. So we can kind of go back. I'll typically talk in percentages. We also have the median. So the median kind of tells us where the middle point of the data is. And depending on the example or situation, this might be more useful, right? Because what's the mean going to be impacted on? Well, let's say I want to know the average income in the US, right? If I've got billionaires in there, they're going to pull the average way to the right. But what the median does is say, okay, I'm going to treat every observation the same. I just want to know what value is smack dab in the middle. If I arranged all the incomes from lowest to highest, what income value is smack dab in the middle such that 50% of the data is to the left, 50% is to the right? Well, now it doesn't matter if that billionaire has $1 billion or $1 million billion or $100 billion, right? It's going to influence the median the exact same amount because it's just getting canceled out one time. So sometimes we might rely a little bit more on the median because we know it's a situation where we might have some extreme outliers. The mean is going to be a little bit misleading. And then the mode, this is going to be the value that occurs most often in your data set, right? When we look at the standard normal distribution, typically all 3 of these things are the exact same value. But to the point earlier, a lot of variables will have skewed distributions, right? But these are going to be our 3 main measures of central tendency. Probably talked about these in 370. I don't think I'm probably blowing anyone's mind at this point yet. Okay. And I should mention the way that we kind of denote these is a capital M subscript D, capital M subscript O for the median mode. If we wanted to look at sample data, we just make those lowercase. Okay. What else do we want to do? Variance here. I might dive back into this, but I want to make sure we have enough time. Maybe get you out of here a little bit early since it's day 1. I want to make sure we have enough time to kind of go back and work through, see how you get state on your computers. Okay. So any questions from me? We'll probably pick up on variance. Like I said, maybe I'll finish with it, or maybe we'll start with it on Thursday. Any questions from you? All right. So, let me see, is that a good stopping point for us? Well, yeah. So let's go here. So I've got under the Files tab. Well, first of all, I have this useful, this won't be useful too much yet, but this kind of has a nice little summary. This computer, hopefully don't get the spinning wheel of death. We might. So I don't know, sometimes on campus, this is an issue. I don't know why pulling it up on the interface is such an, something I shouldn't be saying. But just downloading the file, probably a little bit easier. I don't know why it takes it a long time to kind of open these files on Canvas, but just downloading it. This has like a really comprehensive list of like a lot of stuff that we'll be talking about throughout the semester. Right now, it's not going to be as useful, but it's a good kind of additional reference for things that we're going to be doing. And it kind of just puts it all in one central location. But if we go to week one materials, up here, I'll get it added in here. Should be there. I might have accidentally put it somewhere else. So these steps, once again, I know that this is going to happen. I should just download it. I kind of have what I'm going to talk through written down in a Word document, and that's up now under the Files tab under week one. But I think we'll walk through it. Hopefully, it'll be a little bit easier to kind of see me actually work through all these steps as opposed to reading them. So the first thing we're going to have to do is you'll go to one.iu, and well, it's already pulled up here, but if it wasn't, we're going to go to cloud storage. Click on cloud storage. We're going to log in using, if it doesn't do it automatically, use your IU login information. Now notice here I've got my OneDrive selected, so I can't like well, not going to undo mine, but usually if this doesn't have a green check mark next to it, there should be a button down here that doesn't say deauthorize, but it says authorize, right? So you want to make sure you click that so that it's authorized. After that, you should see this green check mark next to this OneDrive IU. And don't use the personal one, make sure you're using the IU one because this data program works through IU anywhere, so we need to make sure we're kind of keeping everything on IU, okay? Any questions on that? Is anybody doing that right now? Might be helpful, okay. If you run into any problems, let me know as we're working through this. So once that's selected, go back to one.iu. And now we'll search IU Anywhere. So here's this. Have you guys used IU Anywhere for any other courses? Seen a couple nods, yes, no. Okay. So you'll click on IU Anywhere. You'll have to then click on Login. Now I think, I don't know, mine's like automatically doing it. It might prompt you once again for your IU email address and password, so you'll have to enter that. But once you do, you should see this like Welcome to Citrix Workspace app pop open. Is anybody working along with me seeing that? Okay. You should be have this option. I think once you do it once, you shouldn't have to go through this step. I have to go through this step every single time because they will like wipe these computers every single like 24 hours or whatever. So you'll hit Detect Citrix Workspace, you'll agree, you'll hit download. See it's starting to download here. Once again, you shouldn't have to go through this only one time with Citrix part. Okay? Once you have that downloaded, we'll hit continue. Let's see here. I'm going to actually go up here. So I've got this download. There we go. I'm going to click on it. So it's trying to open it. It might be a little slow since it's week one and a lot of people are on here. Oh, okay. Maybe it was already trying to automatically run it. I was just impatient. Okay. So welcome to the Citrix Workspace app. Hit continue. I agree. We're going to install this. And usually I'll have this done at the very beginning. I'll do this before we start class, so you guys don't have to watch me do this every single time. And this might take a little bit of time to get. So we'll wait. Still going. Sorry for the dead air. Almost there. All right. So got Citrix Workspace open. I don't even think, I just said, use my IU email. Back to this. Okay, so once it's downloaded, go back there, show you that again. Let's go to IU Anywhere. Oh, now I can't. Okay, I did it too fast. So once you do have it downloaded, you don't have to, when it prompted me for my email address, so you don't have to do it through there. You'll just go back to IU Anywhere. You'll have that Citrix thing. It'll automatically should open up Citrix for you. And it sends you now to what looks like this screen. Did anybody get downloaded, sent this far, and get snagged somewhere? Did anybody get hung up, or everybody can see this screen now? Then? Okay. I think I think that thing is a little bit different because it's a university computer and this gets white. But like now that you have that done, you shouldn't have to ever go and do that again. So now once you go to IU Anywhere from one.iu, you go to log in. You shouldn't have to go through that whole Citrix process out again, okay? Unless you get a new computer or something. So now that I'm here, I'm going to go up here to apps, and under apps, I'm going to scroll down all the way at the bottom, and here's the Stata SE18, right? And I also go back and forth. Everyone says it different. Stata, it's kind of like data, right? It's so whatever you want to call it, I'll know what you're talking about. Right? So we'll click down here. We should now be able to open this. Okay, so are you guys seeing the open option? Hopefully, yeah. So we'll go to open. Always going to allow this, even though I'll probably have to reset this every single time. It'll connect. It'll take a little bit of time. So this is one thing where I'm going to do all this before class starts. Probably be a good idea if you did, got this open up before class starts, because it can occasionally take some time. Because it's like, I think the way that it works is, I'm not like the most tech savvy person in the world, but I think it's operating like off of some cloud. So it takes a little bit of time sometimes for it to pull it open. All right, so there we go. So hit OK, check for updates, everything's good. This is now, we've got the program running, okay? So we've got this program running. There's nothing in it. So I'll just walk through a couple of things. So usually if I go up here, so how many of you, do any of you know or have used R or Python? A couple of you. So this is like probably going to be a little bit easier, or this will be easier. So the reason why I don't use R yet, I know that especially for Kelly students, they really like it because it is kind of the industry standard a lot. It's not as user friendly. The interface isn't as nice. It's a lot more coding. I don't think that there's really any course that like requires coding that's a prereq for this. So I'm going to kind of use Stata instead of R. Once we get to the end of the semester, if you're interested in learning more, I can point you to some things like DataCamp has some good R program. And you can do everything we do in this class in R, and it's just it's a different language, right? You can say the same thing in English and French, it just sounds different, right? It's just a little bit different of the syntax, okay? So if you're ever interested in learning some R, I do know some, excuse me, resources to point you to. So here we've got this nice little user interface, and this is data editor or data browser. I typically never open the data editor because you shouldn't be editing your data. Like you shouldn't be manipulating the data. But so usually what I do is I hit this data editor and it should pull up my data set. Well, now the problem is I don't have a data set open yet, right? So it's just blank, right? Now eventually it'll open up some data. I have a bunch of different subjects. I can collect different variables will be my columns. So how do we do that? So I'm going to go over here. Another thing that we use in Stata is something called a do file. So this is like where all of your output and where everything that Stata is doing, like all the code that it's running, it'll put it here like in the actual program. But your code, you want to save it, right? And you want to store it somewhere else, which is what we call this do file. So you'll click on this little icon. It opens a second screen. Well, let's kind of put them side by side. This is typically how I work. I do this like side by side, right? So this is my do file, right? And this is where I'm going to start to kind of type in my code and then save these files so I can go back later and rerun this code, right? Because every time I close out this program, the data like goes away. I have to reload it and do everything else again. So one thing you can do is if you know how to code, you can just start typing away, right? But This is why I use Stata. It's a lot easier. If I go to file, import, and I think the one I have, I think it's a CSV. Hopefully we'll see if I'm right. So if I open it, I want to open, there's like Excel spreadsheets, right? I probably what you saw in 370, you could see data sets in Excel. They might be stored in what we call CSVs. It looks like Excel, but it's a little bit different because it stores it slightly differently behind the scenes. I think that's the data set that I have. A lot of data sets we will start out with are in that format. All right, so I went to file, import, and I clicked on this text data or this .csv. I'm gonna have to move this because it moved it behind it. There we go. So I now have this little box. What file do I want to import? Well, I have this 371. I have the kind of data files. These should be the two. Let's make sure that I'm telling this correctly. There we go. So if we look at the data files here. Oh, I actually had state cigarette tax. So I'm gonna download this. I'll kind of show you how you can do this. Two different ways. So this should be in our downloads now. So we'll go back. So I'm going to go to downloads. Will not let me access downloads on this computer. No. All right. Oh, I'm in the wrong. I was gonna say I could have sworn I dropped it. Sorry, I was in the wrong folder. So week one materials file. Here we go. There it is. There's my state cigarette tax.csv. Once you download it to your computer, you can access your own downloads. I just can't access them because this is a university computer. This is why I have to use my OneDrive. So it's probably good practice for you to start putting everything on your OneDrive so you can access it through, it's always going to be in the same place. But if you do like download it to your device under downloads, you can still do the same thing, right? You can open these files from your own personal computer, your own personal files. So I select that .csv file, I hit open. It gives me kind of a preview, right? And I can see all the data. So I've got a bunch of different countries. I've got a year. I've got, this is like cigarette taxes and cigarette use. I'm gonna hit okay. We're gonna get rid of this so that we can see what it's doing. So it ran that, essentially, it created this code and then it ran it, right? Now, it looks kind of goofy because I have the window small, but if I extend the window, so if I were to do that again, it's kind of personal preference, but so 6 cigarette tax. No, it puts it all in one line, but if it's too small, it kind of has to like separate. So what this is it kind of told Stata, import this file, right? And then clear out any existing data that was already there. So just good practice, what I would generally do is, okay, I use Stata to do this nice thing for me. It got the format perfect, so that really helps me out. I didn't know to import it. I had to put delimited there, so that kind of helps me. So I'm gonna highlight this, copy it, and then paste it, because if I ever want to do it again, I don't have to go through all those steps. Once I have this code, if I highlight the code and then go up here to execute or do, that's why they call it a do file, do this code or execute this code, it does it for me again. So that way, if I save this do file and I close out of the program, I can open the do file and just reopen that data set again. Now, another thing that's kind of good practice, you'll see this a lot in the stuff that I put up on Canvas, is to create a global, right? So especially if you're storing everything on your iDrive. So for instance, all the files I'm going to use in this class will always be in my iDrive or my OneDrive, and in this folder, in this classes folder, in this sections folder, right? So anytime I open any data set, I know that I'm always going to want, we're going to call this, so we're going to put quotation marks around this. This is the file path I always want to use. So global says I want to define a variable. I'm going to call it path. And what I want path to be is whatever I put next, which is this string of text that identifies where my files are going to be at. So I've now got this global variable path. I'm gonna get rid of this because I've already got it up here. Put $, and then brackets, and then put the name of my global variable in those brackets. So what this will do is say, okay, look, once I define that global path as this string of text, anytime I put the $, in the brackets and path, it'll put that string of text in there. Now, this is helpful and useful because if you are jumping from like, this is why I use it, because I sometimes will be doing this on my personal computer, sometimes I'll be pulling the files from my OneDrive, sometimes I'll be on a different computer. I can always change whatever that global path is, right? Sometimes I've got like a USB drive, sometimes I'll pull it from that. I can always go in, and it's gonna be the same files, right? It's gonna be the same file, it's just that it's gonna start out in a different location, right? So now if I do this, I'll run this line of code here. It defines that global variable, and then it doesn't even show me, but it's putting that in there, and it's opening the exact same data set, right? So it's just kind of a good practice thing. You don't have to define the global like that. I just do it because when you are jumping across different computers, it makes it life a little bit easier. But if you're always going to be on your personal device, by all means, do that. Okay. So just to kind of some more things about Stata before we end it here a little bit early. You know, once it downloads this, notice here I've got what? A bunch of different states across multiple points in time, different years. This would be what type of data set? Talked about cross-sectional time series panel. If I've got multiple subjects, multiple time periods, this would be panel data. I'm okay with awkward silences too. I'll wait for answers. So if you guys want things to move along, it's just a conversation, right? It's not just me talking at you. We also can see here I've got multiple different variables, right? I can start to do things like basic math. So let's say, for example, I wanted to take tax revenue and let's say I want to take the state tax and add it to this tax per packet, right? I could go back to my do file and say, okay, look, oops, that's not what I want to do. I want to generate a new variable. I'm going to call it total tax. I don't know if tax per pack is state tax or national. I'm assuming it's national. We're just going to act like it is for this example. So my total tax is going to be the tax per pack from the national level. Excuse me, and add to that the state tax. Right? So instead of doing this by hand for every single observation, I'm going to have Stata do this for me very quickly. So that gen command tells it, I want you to generate a new variable. You have to then tell it, well, what is the variable's name? I'm going to call it total tax. And then what is this variable going to be equal to? I can put spaces here too if it makes it easier to see things. In fact, someone should have said something at this point. I generally do this at the beginning of class, but since I was kind of showing you how to get everything open, I forgot. Hopefully that makes it a little easier to see, but I'll kind of change the view there. So I want this new variable to be equal to the sum of these other two variables. I'm now going to highlight this, hit enter, go back to my data browser. Now I see, oh yeah, I've got this new variable, just added those two together. Right? So I can use multiplication, or I can use division, and I can create these new variables based off of these original variables that I downloaded with the data set. So we'll be doing some of that as we kind of work through examples the next, the entire semester. I also wanted to, now the reason why it's kind of good practice to, let's say I do a bunch of work with the data and I manipulate some of the variables and then I realize I made a mistake. Well, that's why it's always good to have this do file saved so that I can like clear it back out, start with the original data again, and then just go to the point where I knew I made a mistake, right? If I just type all of my code in here, I gotta type it all over again, right? So using this do file, kind of saving these do files, it's just gonna be a lifesaver. Let me think if there's anything else I want to point out here. Start to do some other things next class. So this just should get us started. One thing, obviously I'm not tying points to it, but before next class, you get on and do that background survey. That really helps me out, kind of cater this class to you guys. Also, I would highly suggest trying to make sure if you didn't during class today, to be able to pull open that state on your, which, did any of you guys get to that point? You have the program open and everything? Okay, so make sure you have that done by Thursday as well, and we'll start, I'll start bringing in some P files, posting some, I think there's already some P files posted, that we'll start working through, you can kind of work along with it, okay? Other questions from me before I let you guys get out of here? Okay. Yeah.
Can you just show what the data set looks like after that generates?
Yeah. So if you just go back here, look at, it created this new variable, so this wasn't there before. And it was taking that tax per pack, adding the state tax to get that total tax value. Yep. All right. All right, we'll try to stay cool, and I will see you guys back here on Thursday.